Ladies and gentlemen, welcome back to another live stream. Right, so let me share the stream in my Discord server. You can join my Discord server down in the description below. Let's pull out the chat. So today we're going to be continuing our Zig Vulkan experiment that we started yesterday. So this is kind of like part 2 essentially. Alright. Okay, so we're gonna be waiting a bit for a few minutes and then we can start. Just waiting for people to join in while I'm drinking my coffee, and then we could start, pretty much. I'm gonna start in a few minutes or seconds. So I guess maybe we're already gonna start. Okay, so we're gonna start at the 5-minute mark, fine. So we got like 2 minutes left, so if anybody wanna join in, they can. Okay, I guess let's just start already. Hello, Mucho. Long time. I remember you from the Rust live streams. Yeah, I was talking about Velo and stuff, yeah. Rust and Vulkan, yep. Right now we're doing Zig and Vulkan. Zig and Vulkan. Anyways, I guess let's start already. So this is part 2. Stream equal to new stream. Yeah, video stream. Craft Trumsen, welcome to the live stream. Welcome back. Alright, so I guess let's just start. So yesterday pretty much, we got a simple just like clearing the screen with the red color, but we had a few issues, and let me just discard these changes that I've just done here and pull one commits. Fine, why not? Okay, so obviously I put this already on, GitHub. So if you like to see it, you can see it. In fact, even like the previous live stream, it's actually available offline. Not offline, I mean like, it's, so after the live stream was done, I saved it essentially. So right now it's basically kind of like a video you could rewatch essentially. I also added like chapters to it and stuff. Now, obviously all these live streams would be like kind of like spontaneous. I'm not preparing much beforehand, so you're gonna see me like how I'm gonna explore all this stuff together pretty much. And yeah, all right, so let's see what we got last live stream. Okay, so we just got this guy right here, this red window, and we have a few validation errors that we're gonna remove right now. It's actually a very simple fix. Other than that, we're also gonna make sure that resizing also works, because right now it's not great. Okay, so what's wrong? So pretty much as you've seen in the previous live stream, we have adopted the Swapchain code of the example we were following of Zig GY, like Zig, what is it called? Zig Vulkan, okay. Zig Vulkan Zig, and like examples. Right, and we basically have copied over the Swapchain and just like changed a few things. Sorry, like the GFW window, we've made it like use SDL3 instead, pretty much, and that's exactly what we have so far. Okay, so what we're gonna do now is we want to change something, which is here. So in the present function, they're actually waiting on the fence and they're resetting the fence. But the thing is, here, since we're actually re-recording the command buffer every time, every frame, in their example, they're basically pre-baking all the command buffers once. Here we're actually just doing every frame, so it's a little bit different. So we gotta change their code, kind of like adapt their code. So instead of like waiting for the fence and resetting the fence here, which is like in the present phase, which is like after the recording and everything, no. What we want to really do is take this code and come to here. Now, before we reset the command buffer, here we gotta make sure to first of all wait for the current fence, then reset the command buffer. Otherwise, you're gonna get these issues, these synchronization issues, because you're basically like trying to edit the command buffer while it's still executing in the GPU or whatever. So yeah, and also let's grab the current thing from here, why not? And there we go. Here we don't have any self, we just have Swapchain. Current Swapchain image, and here we got just GC and just GC, and there we go. All right, what else we got? I think that should be good to go. Other than that, we also got here the command buffer. So we're actually setting it up here, but the problem is if we got to recreate the Swapchain here, we gotta have a problem because it's no longer the correct image index. So what we're gonna do, just gonna take this command buffer and set it until we actually even need it, which is right here. That's the second fix. The third fix is that right now we're just hard coding this extent. But instead of that, what we're actually gonna do is, well, we're actually using this. Yeah, we're using it in a few times. So we're just gonna give it the swapchain.extent, and that's basically it. Cool. Other than that, here we're gonna have, so like if the window is minimized, we're gonna have a spin loop, which means that we're just gonna be running this loop as fast as possible, which is just gonna be like burning the CPU for no reason. So here they were actually doing GFW pull events for whichever reason. In our case, what we're gonna do is, this is something I learned from MGY. is that you just, I believe, say wait event. And in fact, they didn't have this exactly. They had some other code, but I kind of got into this solution, which is to basically use SDL wait event here. So wait until you got an event from SDL. And yeah, so here it needs, so we could just say null because we don't want to consume the event. We just want to wait for an event. And once it's done, we gotta check again, basically. Okay, cool. So we could just remove this. And so far we should be good to go. So this is all it takes to actually fix the window resizing problem and so on. Value type bool ignored, wait event. Yeah, this is what annoys me about SDL, is that every single function could fail. Like even the most naive ones could fail. But anyways, try check SDL. And wait for fences is not marked public. Yep. So where is wait for fences? Here. Let's make this public. And zig build run. And now what? Expected. Oh yeah, let's give it the reference of GC here. Alright, and right now we got no validation errors at all, and we got a perfect, oh, what? Wait, we have one extra thing that we gotta do is to make sure to wait for the device to be idle before we try to recreate the swap chain. Otherwise, we could try to recreate the swap chain while it's still being used by the GPU. So what we could say is, what is it called? gc.dev.waitIdle. Well, device wait idle, pretty much, yeah. And here we can say try, and yeah, that's pretty much it. So zig build run now, and there we go. So as you can see right now, we have no problems at all. So we got a perfect Vulkan clear screen, perfection. Okay. All right. So now what we gonna do? Good question. What do you guys think should we do? Should we first of all like make this into an abstract? Or should we just go straight into pipelines and shaders and so on? What do you guys think? Should we organize this into an abstract or go straight into shaders? I guess maybe let's just organize this first. But first of all, yeah, shaders, okay. So someone have said shaders, so I guess we're gonna go with shaders, fine. All right, so first of all, I'm gonna commit this changes. So this is like fixing the colored window, perfect, and sync the changes. Fine, whichever. Anyways, so now let's see how we're gonna figure out this shaders, because I have no clue how you do it in Zig. I forgot completely what's up. So let's see. The only thing that I kind of prepared like off camera is just that synchronization issue. I've kind of tracked it down of the swap chain, that's all. But other than that, we're gonna, yeah, full screen quad. Okay, wait a second, I'm gonna open up the windows. I have a problem with Windows. It's either like I'm gasping for air and it's too hot, but too noisy and too cold, or the other extremes. So if you open the window, you're in a problem. If you don't, you're in a problem. Anyways, classic problems. All right, whichever. Okay, so let's see what we're gonna do right now. Let's see. So let's see how the example have done it. Oh my god, what the heck? Bruh. No one calls me bro until I have a live stream. That's great. Anyways, triangle.zig. Alright, let's see what we got here. So embed file vertex shader and embed file fragment shader. So where are these shaders though? My god. Anyways, shaders. Okay. My God. Anyways. Oh boy. Sorry. Anyways, let's go back here. Man. Anyways. So we got this triangle.vert apparently. We got this triangle fragment shader. And what are these? What? Fragment.zig? What the heck? Can you actually create like shaders using Zig? What? Bruh, am I dreaming? Or what the heck is this? Wait. I'm kinda clueless. Yeah, I mean it's right here, but like, what? I'm not sure how does this work. Wait, let's ask ChatGPT. Can Zig compile to SPIR-V? Bruh, what? But how? Lacks full Vulkan feature coverage, has limited. You know, we could actually toy with this later on. But for now, let's just go with the standard stuff. Oh my god. Alright, anyways, let's grab this triangle.vert and triangle.frag. And, I don't know, let's say maybe assets. Okay. And what are we gonna call this again? Triangle.vert, I think. And there we go. Triangle.vert, or should we call it just shaders? Pretty much fine. And we probably need it in the SRC because we're gonna just import it, like embed it into the binary, because Zig actually allows us to do that, kind of like Rust. So also we're gonna need triangle.frag, so let's just grab this, though we're gonna change the shaders a bit. Because I don't want to deal with buffers right now, so I'm actually just gonna let ChatGPT just generate an array of vertices and just use those using GL vertex index. I could never remember the syntax of GLSL, so convert this into using an array of vertices with GL vertex index. Okay, that's cool. So we're just gonna go with this for now. So right here we just have like a kind of like a constant array of vertices of type struct vertex, vic2 position, and vic3 color. We don't really need color, it just added it here apparently. But fine, whatever. So we got vertex v equal vertices, and we use GL vertex index to kind of like select the vertex that we want. And then we just send it to the GL position, and that's basically it. All right, that's sick. So now how are we gonna handle this? Let's see. Shaders, triangle.zig. So what it did, wait. Embed file vertex shader. It's probably not including them here, right? I would guess so. So let's just try to actually like compile them ourselves. So we're gonna say glslc src slash shaders slash triangle.frag, and yeah, and there we go. I got a.spv. So just rename this really quickly, and let's call this triangle.frag.spv, and let's just put them here, fine. And let's go to the next one, which is triangle.vert-o, and we're gonna go with src slash shaders slash triangle.vert, right, .vert.spv. We could probably handle this using like the Zig build system, but whatever. And yeah, that's pretty much it, I believe. So we got these two. Right now we could basically embed them by doing this. Let's just copy it over, fine. And let's come here to main.zig and let's see what we got. So vert SPIR-V, here we basically make sure that it's aligned to U32. And here we embed the file, Vertex shader. So I think probably we need to wait. Embed file, this function returns a compile time constant pointer to null terminated fixed size array with length equal to the byte count of file given by path. The contents of the array are the contents of the file. This is equivalent to a string literal. Is with the file const path is absolute or relative to the current file, just like import. Okay, so it's relative to the current file, which is main.zig. So we're just gonna say shaders. So shaders slash. I wouldn't be surprised if they like have a build step here to actually compile it. Yeah, I wouldn't be surprised, but anyways, whatever. So I'll just say shader slash triangle.vert .spv, and that's basically it. Now next, go here, and say .frag, and that's the frag SPV. Okay, so I guess that should work. I mean, it seems to be good so far. So now let's actually figure out how we're gonna create that compilation stuff. Honestly, if we could just like copy that stuff, because it's just like a lot of boilerplate for no reason. We don't really need vertices right now. The only thing we're gonna need is the pipeline stuff. So we don't need a render pass because we're using dynamic rendering, which is the new way or the modern way of doing it in Vulkan. But we still need obviously a pipeline. Yeah, so where's the create pipeline here? Okay. So it basically takes in a layout, and in this case render pass, creates a shader module, return pipeline. Okay, I guess I'll just copy this part, honestly. A lot of boilerplate for no reason. So let's just do this. And let's see what we got here. So we gotta actually adapt this to dynamic rendering instead of a render pass. So we don't have any render passes. We're only obviously gonna have a pipeline layout. And here we're creating a shader module with the vertex shader binary. And what else? We're destroying the shader module. Create shader module frag SPV PSCI. Everything seems fine so far. Oh, here we were not gonna need this vertex stuff for now. So what we're gonna do? Let's see where this is being used. It's being used here in the vertex input state. Can we, I guess, set it to null? I think maybe we can, or maybe we can't. Let's see. Or you know what? Let's just only remove that part that we don't need right now, which is this vertex binding stuff. Okay, fine. Now, does it have defaults? Yes, it does. It's cool. So what we're gonna do, just gonna remove this part for now. Yeah, we're gonna actually remove all of this pretty much. Just gonna be empty. And that's basically it. Okay, so obviously triangle list, great. Viewport count 1, view set in, create command buffers with command set viewport. Wait, viewports. Yeah, okay, cool. Clockwise. I wonder about this clockwise, if it's anti-clockwise or clockwise. Is there like a front face which doesn't call anything? Yeah, there's this back bit here, but anyways, I'll just keep it like leave it alone for now. Fine. Okay, so right now we're gonna remove this render pass and we're gonna figure out how we could use dynamic rendering for this. So let's remove that render pass and let's figure it out. And I actually forgot. So let's look for Vulkan. Well, what is it called? Dynamic rendering blog that we had like in the previous live stream. So let's see. It was like a C++. There we go. And this one is quite nice. All right, so let's see what it did for the pipeline part. Okay, vk rendering info, blah, blah, blah. So, okay, here we go. The pipeline creation. Now we are at the point where we can scrape out all the code initializing render paths and frame buffer objects. And when creating pipeline objects, we no longer need to specify a render path, but instead we need to create a vk pipeline rendering create info object to specify attachment formats. Okay, so here we got a struct of kind like vk pipeline rendering create info, is it? Wait, what? No, wait. .pnex pipeline rendering. Yeah, pretty much. Okay. So fine, pipeline rendering create info. Pipeline rendering create info. Okay, let's add that. Why not? So where are we creating that thing? There we go. Okay. So pipeline. I don't know what to call it. Pipeline rendering create info. Okay. Pipeline rendering create info. Okay, let's see what we got. Well, this is gonna be vk.pipeline rendering create info. And let's see what we got. So color attachment count is equal, I believe, to 1, and then the color attachment format. So here, instead of like having a render pass and frame buffers and all that business, you just tell the pipeline what kind of formats you're going to be using. So that's as simple as that. And yeah, okay. So let's see how we're going to do this. We're going to say ptr cast, and we're going to give it a reference to vk.color attachment or something. What is that called exactly? Oh, format, my bad. Okay, so well, the format we gotta get it actually from the Swapchain. So we don't have like access to the Swapchain here, right? Yep. So I guess, or you know, let's just call this format, right? Let's just grab the format here. So vk.format, and let's pass the format here. Where is it? Okay, here. So I guess just like that. And now what's next? We gotta, I guess, just say pnex is equal to that. Okay, cool, lovely. Pnex is equal to pipeline. Wait. Why this doesn't appear here? That's strange. Okay, so this seems to work. Amazing. So now let's see where we're going to be using this create pipeline function. So obviously it requires a layout. So let's create that first. Okay. So let's do it here. So we're going to create a pipeline. So const pipeline is equal to create pipeline. And here we give it the graphics context address, and here the layout, the pipeline layout. And the format, which we're going to grab from the Swapchain, hopefully, if we can. Surface format.format. Cool. Now the pipeline layout we're going to create it ourselves, or I mean, it's probably very simple to create, so no need to steal it. So yeah, fine. Let's go with pipeline layout is equal to what? vk.pipeline layout dot. Oh wait, no, my bad. gc.dev.create pipeline layout. And here the create info. So vk.pipeline create info khr dot, well, not pipeline create info, what the heck? Pipeline layout create info. There we go. And we don't need anything here for now. and the allocator we're just gonna say null. And yeah, so we're just gonna make sure to say try, and there we go. Okay, so let's say try here too, and we should be good to go. Now what we're gonna do next is we're gonna use that pipeline in recording our command buffer. So we're gonna come here into after begin rendering and before end rendering, we're gonna do gc.dev.command bind pipeline, I think. Is that the case? Yeah. Bind pipeline, and here the command buffer, which is cmd buff, and the pipeline bind point, which is going to be graphics, and the pipeline here, which is our, well, obviously pipeline. And could this fill? No, we can't. All right, cool. Next up, we gotta try to actually draw something using that pipeline by saying draw cmd draw command buff, the vertex count. We're gonna draw 3 vertices because we have an array of 3 vertices hard coded into our shaders currently. Later on, we're gonna try to use buffers. And the instance count, I believe 1 instance, and the first vertex 0. First instance 0, and there we go. Perfect. So I wonder if this would work, or did I miss anything? I probably did. Let's see. Okay, so the pipeline rendering create info. Pipeline rendering create info. Okay, so we gotta fill out the other stuff. Depth attachment format is equal to undefined. Can we do that? Yep. And what else? Stencil attachment format undefined. We're not using any depth buffer or stencil buffer yet, at least. And is there anything else? Missing struct field, view mask. So I believe the view mask is probably 0 as always. And okay, so what's the problem? Let's see. Oh yeah, we probably haven't set the viewport just yet, right? Dynamic scissors, there we go. So we haven't set the viewport and the scissor. So where are we gonna set those? We're gonna set them in while we record the command buffers. So we're gonna do this. I mean, we could do it here, for example, or something. I'm not sure. Whichever. I mean, what the example is doing, because I don't think the order really matters in that case, or I could be wrong. But let's see where they're setting the viewport. So they're doing that after the begin command buffer and before the begin render pass. Okay, that's interesting. All right, fine. Let's do it before the begin rendering too. Why not? And let's just set the viewport here. So cmd set viewport, and here the command buffer. The first viewport is 0, the viewport count 1. And here we're gonna basically ptr cast vk.viewport, and the width is equal to the extent width, and the height is equal to extent.height. And what else? Max depth and minimum depth. So I guess the minimum depth is probably 0 and the max depth 1. Or is that the case? I think so. Where is the viewport here? Yeah, pretty much. So that's cool. Though here floats from integer. Okay, so this is an integer. Right. So let's actually say float from int. And oh boy. What? Wait. I'm trying to close this, but it's not. Okay, there we go. That's weird. Okay, now let's just take this here, and let's take the same thing here. Float from int. Extent.width. Alright, so that seems to be, I guess, working. Next up, we gotta make sure to set the scissor too. So gc.dev.cmd set scissor. So So here's CMD buff, and the first scissor 0, scissor count 1, and here ptr cast, and we're gonna say vk.scissor. Oh, I think it's probably just a rect or something. Yeah, it's probably just a rect2d. Yep, so you give it the offset and then the extent. So the offset is basically x0 and y0. Next up, you give it the extent, which is going to come from the swapchain.extent. And there we go. Okay, so that seems good. Now let's try zig build run, and missing struct field x in where? Here. Okay, so apparently I missed that. Fine, 0. And the y is 0. There we go. Next. Okay, so we got our triangle. Perfect. So I guess maybe right now we're gonna handle the buffers, right? Because right now we're not using buffers. We're just hard coding the vertices in the shader itself. Though, let's actually see if we can like use Zig to compile some shaders. I wonder. Can we look back into that? Alright, so what changed? So how to compile current approach. Typically Zig build obj shader.zig dash target SPIR-V 32 Vulkan MCPU baseline. Okay, they should output an SPV module can load in Vulkan. Ooh, okay. Practical advice. Okay, I mean, let's try this. Let's try this, why not? So, first of all, we gotta basically try to translate our shaders to Zig. So let's just let the ChatGPT do this. Okay. So translate these to Zig shaders. And let's see if it would work. So if we take this, and let's just make some shader. Shader.zig. Let's try this. Alright, so how are we gonna do this again? Zig. So let's try this part. So zig build dash obj shader.zig and dash target SPIR-V 64 Vulkan. Root source file struct GPU has no member named built in. But it did give us like shader.spv, though it's probably empty. Yeah. So I mean, let's see. Yeah, that doesn't seem to work. And I don't think I'm gonna find documentation about this at all. So like Zig GPU shaders. Okay, so this is the command that you use. Yeah, nah, I think I'm not gonna use this. Yeah, not gonna use this. Maybe later. Alright, so let's just move to trash for now, and let's just keep this. Okay, so what we're gonna do next, let's actually try to use buffers now. So where are buffers? Buffers. Okay, so buffers are actually quite complicated because we're gonna do a staging buffer. Oh man. Oh man, where do you even start? Let's see. So I guess let's start by basically copying this vertices stuff. So vertex stuff. Okay, main.zig. And I'll just put this here. So this basically have like an array of vertices. And this kind of like just declares the binding descriptions and so on. So that's good. So now what? Well, first of all, we gotta actually use right now the, or you know what? Wait. Let me first of all commit this. So this works, right? Yeah, this works. Okay, so I'm gonna commit this, and we don't need this. Let's remove that shader.spv. Move to trash, and let's just commit this. And what we're gonna say is triangle. Let's just say that, commit. And there we go. Next up, let's actually try this stuff. So first of all, we're gonna change the shaders to whichever we have here, which is basically, wait, why we have a vertex.zig here? Oh yeah, see, anyways, let's just say triangle frag. I believe it's pretty much the same thing. We haven't changed this one, but let's just make sure. So triangle.frag, yeah, we haven't changed that one. And triangle.vert is what we changed, so let's get it back. And what we're gonna do is we're gonna try to say GLSLC again for the vertex shader. And we should be good to go. Cool. Now let's see what we're gonna do next. Triangle.zig, and let's just copy this part. And let's go back to main.zig here. And let's just paste this in. And we're good to go. Next up, what we gotta do. Create render pass, create pipeline, create frame buffers. Okay, so this is what we need. We gotta basically create a buffer here. And then we gotta upload the vertices. So let's just copy this part, to be honest. Fine. And let's see if we can get it to work. So where's our main code? So I guess after the pipeline, yeah, and before we create the command, well, after the command pool, apparently, huh? I mean, whatever, let's just try this out. And here we got upload vertices. So let's go to upload vertices. Let's just copy this one too. And let's see. So here we're creating a buffer, cool. And it also needs a copy buffer function. There we go. Let's just copy it over. And so it takes a pool, a destination buffer, and a source buffer, and a size. And it's basically allocating a command buffer for init. Alright, so that seems fine. Alright, so let's go to the next step. So right now we pretty much have created a buffer and uploaded the vertices to it. Next step, we gotta make sure that the graphics pipeline actually have information about the vertex structure. So let's see where we're creating the graphics thing again. And let's just copy back this binding description stuff that we removed earlier. So there we go. So let's just paste this in. And as you can see, we're like giving it the binding descriptions. And I believe they should be good to go. So next, I think we basically have to like bind the pipeline. And how do we bind the pipeline? Oh, well, not pipeline, sorry. Bind vertex buffers. So you just say ptr cast buffer and offset. What kind of offset they're talking about here? I think it's probably just 0. Yeah, there you go. It's just 0. Okay, so let's say const offset is equal to 0. So where we were. So where we're binding the pipeline. So it did it afterward. Okay. So let's do it here. So gc.dev, or you know what, let's just copy this, fine. Bind. There you go. Okay, so we got the offset 0. And actually that should work now. So let's see. Use of undeclared identifier pool. Okay, so we actually called it something else, right? We called it command pool. And there you go. So right now we got buffers working too, which is sick. What we're gonna do? Well, we have a validation error, isn't it? Wait, what's up? The pipeline layout has not been destroyed. Yep. So, and the pipeline also has not been destroyed. So let's make sure to actually destroy them though. Where's the pipeline? The pipeline. Yeah, pipeline light, here we go. So we're gonna say defer, well, gc.dev .destroy pipeline layout. And here we're gonna give it the pipeline layout and null. Alright, so that seems to work. Next up, we also gotta make sure to destroy the pipeline here. So defer gc.dev .destroy pipeline. And here null. Okay, so that's cool. Now if we try to build run, it should have no errors, no validation errors. Yep, sick. So let's just commit this changes to. So we just basically change the vertex shader to, instead of like having a hard-coded array, right now just getting like the vertices, like the buffers essentially here. And next up, this is just like the binary. And here in main.zig we added the vertex stuff, and we added the buffer. We basically uploaded the vertices by creating a command buffer and, you know, transferring it to the VRAM. Essentially, that's why we need an extra command buffer to basically copy the vertices to the VRAM. Next up, we had like a pipeline layout. Well, we just made sure to destroy them properly. And we bound the vertex buffers. And here we added the vertex binding descriptions. And yeah, that's basically it. Okay, so let's just, so this is the buffers, triangle with buffers. And let's just commit all this stuff. And I mean, we could sync changes, why not, fine. Alright, so what we're gonna do next is so I think we pretty much have done everything that we have in the example, right? Isn't it? What do you guys think should we do next? Is the stream still working, by the way? Yeah, it seems to be still working fine. All right, let's think. What do you guys think should we do next? We got a triangle working now. Yeah, I think the example basically end up here. So what we have done so far, just to recap, we kind of like adapted the code of the example here, but we used dynamic rendering and we used like Vulkan 1.4 essentially, and we used SDL instead of GFW. And yeah, so I think honestly, let's try maybe push descriptors. I think let's try maybe, wait, because I'm not sure on the Zig ecosystem, is there like a math library? Well, not this one. Or you could abstract this stuff a bit now. Okay, let's actually do that because I'm not pretty sure what we're gonna do next. So yeah, sure, let's do that. Okay, how are we gonna even start with this? Let's see. So let's just make a struct app, or we could create an app file and just reconstruct this. So app.zig. And what this app.zig would contain is okay. So we're gonna need an allocator, we're gonna need the window, we're gonna need GC. So okay, let's grab all of this stuff. Yeah, pretty much all of this stuff. Let's grab it and let's put it into app.zig. Okay, and next. So let's grab this part into an init function. So let's grab up to here to some degree. Yeah, let's put that there. So app.zig. So let's just create an init function. So pub-fn init void. And let's grab the functions that we got here in main. So copy buffer, apploid vertices. Oh man, how much code? Create pipeline. Let's grab all of them and let's go here, put them here. And there we go. Next up, what we got? So right now we just got this code that runs every frame. So let's grab that too. Well, actually, let's just, I guess, grab all this. And let's go to app.zig. So this is our init function. We're gonna have a dinit function too at some point, but yeah. And here we're gonna have pub-fn run. Yep, run, and it's gonna take in self and void. And there we go. And this gotta be while not self should quit. So yeah, we're gonna bring this part right here. In fact, let's bring both of these and let's put them here. And here we got the allocator, and we're gonna call that basically, well, not var though. This is gonna be fields, so let's remove the var, and it's gotta be a comma here. Well, this gotta be rough. allocator std.mem.allocator. We're gonna need obviously the SDL window too, so we're gonna say c.sdl window, and yeah, so just pointer here. Next step, we're gonna need the graphics context, or GC. So GC would be graphics context. What else? Got the swap chain. So the swap chain is here, and the command pool. So like vk.command pool. There we go. And what else? We got the command buffers. So cmd buffs, command buffer, and we get a buffer here, a vertex buffer or whichever. So vk.buffer. Yeah, that seems good. We also have the device memory of that buffer. Wait, memory buffer or what? Oh, I think it's just memory. Wait, what's the type of that? Device memory, okay. Next up, we got the pipeline layout and the pipeline. Oh my god, all this copy paste and all this abstractions, and we're still having problems. Oh my. Pipeline layout, and what else? Pipeline. Okay, cool. So I think that's basically it. Yeah, I guess. So this should be while not self.shouldQuit. And here we need self. So const self is equal to this. And here we're actually just gonna grab the allocator from here. Yeah, and we're just gonna put it in the main function really. And so let's grab std. And we're good. So we also let's grab app here. So import app.zig, and there we go. And so now what we're gonna do is app.init, and we're gonna pass in GPA, and we're gonna actually try this and defer app.dinit, which we don't have yet. We should create it, and let's just do this. Next up, what we got is app.run. So app.run, well, actually let's do app like this, and app. And here we're gonna say var app is equal to this. And so right now we could just say .run. Okay. But why this? So what problems we have now? So we gotta have pubfn dinit, which kind of takes in self, well, just void, and we're good. And why it didn't accept run there? That's strange, but anyways, we'll see about that later on. All right, so right now all of this defers gotta become error defers, which is kind of annoying, but and not this one's. And we're good. Okay, so how are we gonna do this? We're gonna just simply return, I guess, return. Well, did I actually make it return self? Oh, okay, so that's why. So self. And here we're gonna pass in the allocator. Actually, we're gonna grab the allocator from the init function. cd mem allocator. What else? We got the window, and next up we got the swap chain and the buffer. Actually, let's go with command pool first, and then the command buffers is equal to cmd buffs. And what's next? The buffer, fine, and the buffer memory is equal to memory, and the gc, the graphics context, yeah, so it's just gc. The pipeline is pipeline layout is pipeline layout, and should quit dot state. Now these have default values, so we're fine. So I think that's it. Now what we're gonna do is to just copy all these defers into our init function. So we're gonna do this and this. But wait, without the defer, right? Yeah, without the defer. So just self.gc.dinit, self.swapchain.dinit, and so on. gpa.free command buffers, self.allocator.free, self.cmd buffs. I wonder if the AI could actually like continue this refactor. Let's see, honestly. Let's see. It would probably flip it out, but can you continue the refactor? Do the whole file, bro. Okay, let's see if this would work. Here we go, the dinit function. The run. Okay, so if we do this and try to actually run this now, but we have a little error, I guess, here somewhere. Try upload vertices. Use if undeclared identifier upload vertices. So I guess it didn't include upload vertices for some reason. He probably forgot it. Okay, let's just copy it over again. I don't know why it removed it. And copy buffer too. And now What? Also, bruh. Bruh. Okay, event create pipeline. What happened? What? Bruh. You know what? Control Z, please. Okay, so this is the code that we had earlier. Fine. So just go one by one, to be honest with you. Refactored. Or we could tell it you forgot the helper functions. And let's hope this works. I think we could move on to maybe like creating textures. Possibly. Now it's actually complete. Okay, let's try. Okay, right now I don't have any errors, I think, so that's sick. But how do you do this? So init, cool, the init, and run. Yep. Now let's see if this works. And we have a little error. Missing struct field sharing mode. Did it remove this somehow? That's weird. And sharing mode. So let's just say vk.buffer info here. And now I could just say exclusive. Missing structure. I don't know why it removed a few fields apparently. So it's missing src offset. I would guess it removed them because they were 0. Probably. Rendering info is view mask is 0. My god. Missing struct field depth attachment format. Okay, dot undefined. Yeah, let's just add the other ones too. Dot undefined. Oh boy, primitive restart enable. Here it actually used false instead of dot false. Ah, boy. Swear to God, why you removed some fields from the original code? Don't change my original code. Only do the refactor to abstract. That's so annoying. Bruh. Look at this. What I respected, bruh. Fuck. Anyways, how about we try Gemini and let's see which one would work out well. Oh man. Or you know what? I guess let's just fix this code that we had. Fine. All right. So it's in here. Oh my God, where it is? There we go. So it's in create pipeline. Why it doesn't give me the line exactly? That's crazy. Pipeline rasterization, state create info. Bro, what? In P rasterization state, there we go. Okay, so let's go here and yeah, I gotta make sure that this is vk.pipeline rasterization state create info. There we go. Now we could say rasterizer, or you know what? We could just copy this part again of the pipeline, really. Yeah, we could do that. Could do that. So where's the pipeline stuff now? All right, so let's just actually copy this whole thing. Well, actually, it's not gonna include our changes. Damn. Well, let's just copy this P rasterization state part at least. So it's actually PRSI. So where is PRSI? There we go. Yeah, there we go. Okay. The pipeline multi-sample state. Oh man. Okay, let's grab the multi-sample state. Yeah, I think honestly from all of this, it's probably better off to just boy. Where's my code? Oh my god, this is what you get for using AI. God damn. You know, I think I'm just gonna use my original code, because what the heck is this, bro? What the heck was that? I'd rather like just fix my own code. My god, that's insane. Well, how about Gemini? I wonder if Gemini could do any better work. Can you continue the refactor into app? Don't change any of my code. Damn. Wait. I mean, let's see. So ChatGPT kind of sucked because it like omitted some fields, and so let's see if Gemini could do the refactor. I mean, obviously we could do this manually, but if it could just quickly do the refactor for us, that would be great. Although, to be honest with you, I wouldn't really trust it, because what the heck was that? I mean, we tried with, you know, like ChatGPT, keep the existing create pipeline. Yeah, okay. So this is the run, the init function. You know, just generate the whole thing. And let's call it a day. Okay, and hello comported box is amazing. Okay, let's see if Gemini have done a better job at this. We already have some errors apparently. No, actually no. Yeah, we don't have any errors. Okay, let's try this. And we have 2 errors actually. Error union is ignored. Well, this is just our own code. So defer app.dinit and try app.init. Okay, what we got now? Come on, did it also omit some fields or what? Resolve mode is equal to undefined. Or actually what? Wait, no, just this. Hopefully it didn't omit any other fields, cause oh my god. Resolve image layout. Man, this really sucks. Though I don't think that's required. Okay, Zig builder. Okay, so right now LLVM. Oh, right. Well, that's cool. That's cool, but it did change the background color. Is it like some problem, or is it just decided to change that? Do I have the validation? Yeah, I have the validation layers on, so that's great. Lovely. So as you can see, Gemini did a better job at refactoring, continuing the refactor, which is nice. Yeah, let's go. Oh my god, that was insane. That was insane. My god. Okay, the background color part. What happened there? Like, why it became black suddenly? Did it change just the color, or is there's some other problem going on? Yeah, it just changed the color pretty much. But if we wanted the original red color that we had earlier, we just changed this. Yep, pretty much. So just changed the color. So that's cool. All right, so Gemini did a good job, though I do have a not really greatly like paid. It's just like, I guess the Go version. I'm not sure exactly what was it, but yeah, probably the plus version that I have of Gemini. But like even ChatGPT, I have also the Go version. So, but Gemini seems to have done a good job, a better job at least. But anyways, whatever. So I guess I'll just commit this stuff. So this is the whole refactor. So right now our main function just creates the allocator and creates the app, and yeah, we're done. So that's quite sick. All right, so this is the refactor. And let's commit and sync changes, push it to the repo, and there we go. Vulkan is supported in C++. Can we do Zig in C++? We can do Zig in C++, but to be honest with you, I have never tried to like mix two languages together in one place, like in one project. I've never tried that. Have you ever done that? Alright, so Arid Hanush, welcome to the live stream. I was trying to do this the other day, but using Zig purely as the compiler instead. Zig purely as the You mean you used C++, but like the Zig for the build system, or what do you mean? But yeah, since we got this working, I see. I mean, you can make two projects. No, I mean, as this guy said, you can actually use the Zig build system to actually even compile like C++. It's just C++ and C. Because some people are doing that for cross compilation. It's a way better compiler if you are not going to be using like, let's say, CMake, or where is the other one called? Yeah. So honestly, I don't know if this would work. I have no clue where to even start with this one, but let's try maybe to make textures, you know, like a textured triangle. The problem though with this, but actually wait, the problem with this is that the example doesn't really contain that. Mostly only plan to use Zig as a compiler in and itself. Oh, I see. Is there like any particular reason why I did that? Okay. You know, let's tell ChatGPT to actually, you know, let's try to do 3D. Why not? Let's try to do 3D, really. I think the texture would be crazy. I was stuck at making shaders work, as shader C had some CRT mismatch things. The binaries are MSVC only. Oh, mostly because I didn't want to learn CMake. Yeah, CMake is a pain in the ass at the start, but it kind of gets easier after that. You could check out my like CMake kind of videos, and maybe you could learn a few tricks if you'd like to use CMake. But yeah. Alright, I think let's make the ChatGPT to like generate some vertices for maybe the cube, for example. Okay, let's try. Let's try. Can you generate vertices for cube instead? So you replace build systems like Makefile CMake with Zig. Can you also replace compilers like GCC, Clang with Zig? Well, yeah, that's exactly what they're doing. So like the Zig actually have the build system and the compiler. So it's everything in one, kind of. Are you working off the public repo that provides the Zig Vulkan binary? Yeah, I'm using this one. Though I'm using the compatibility tag of 0.15 because I'm using the stable version, which is 0.15.2. ChatGPT is going to be a pain to make an OpenXR app VR in Zig and CMake. Yeah, like AI stuff really kind of it's like a pain in the ass pretty much. So sometimes it works, sometimes it doesn't, especially if you're working on something crazy. But yeah. Anyways, so what we were doing, I forgot. Yeah, we were here. Okay. can generate vertices for a cube instead. I was trying to pick it up without it first. I'll probably jump to it if I don't figure out how to make shader C dependencies work. Thinking to include its source and compile as a step in project. Yeah, it reminded me of trying to get like shader C working in CMake alone. That was a real pain, even in CMake. A real pain. Because I was also trying to compile SDL3 shaders. Like shader, what is it called? Wait. Yeah, shader cross, I think. SDL shader cross or something like that. Isn't it? SDL. Yeah, exactly that. So it's just a shader C issue now. I thought it was just me making a mistake. Yeah, no, it's like the CMake setup of shader C is very complex, especially shader C, because there's just a lot of dependencies right there. Yeah, I don't even remember how did I get it to work. I did get it to work at the end, but you're probably better off using VC package, I think. Yeah, it's like dependencies are always a pain in the ass. But you could use it. But honestly, if you're going to be compiling like at runtime, maybe you'd better try to use GLSlang, maybe? I don't know. But yeah. What about Meson? I've seen it in a lot of low-level projects for build, but never really heard anyone talk about it. Meson is usually used for C projects. Like, for example, the Wayland one, the Pipewire one, and Linux projects in general. Like Linux and C projects, they all use Meson. Pretty much. It was not bad. I mean, it's kind of like Python syntax. I like to just hoard the packages, but didn't look into VC packages. Be just another app to track. Yeah, like VC package could be way easier to set up. You could look out for some of my VC package videos. But yeah, alright, anyways, let's go back into this. If you guys have any other questions about programming, please let me know. We could discuss them. This is just a chill stream, so we're fine. You covered a lot before you jumped to Zig. Yeah, oh my god. Like I've been switching between languages and technologies, like I've gone through everything at this point. It's insane. It's insane. Last time I cared about build system was in C++, where I really liked pre-make for some reason. Honestly, if you just understand a few things about CMake, the problem with CMake is that there's just a lot of legacy code out there and some over-engineered code. But if you just use like the modern CMake way and some few tips and tricks that you could find in my videos about CMake, it's actually not that bad. It's like, really. For most cases, it's not that bad, especially if you use it with VC package too. So yeah, but really when I was just kind of like learning it, oh my god. That was like, bruh, what the heck? Oh, we could actually try to make use of index buffer. We don't have that yet. We only have, oh yeah. We only have that, yeah. I heard of pre-make, but I'd rather just pick up Zig and compile Lua and SQLite indirectly than suffer through C++ build system. Yeah. I never honestly try to use Zig builds. Like, how does the IDE work? Does the IDE work fine? Like, the C++ stuff work fine with Zig build system? I have no clue. But yeah, let's actually use index buffer. Why not? Let's actually add that. Because right now we're not using an index buffer, only using a vertex buffer apparently. Yep, pretty much. So let's rename some stuff around here actually. I run VS Code, so no idea what we're using. Yeah, I'm using VS Code, but like what kind of extension did it give you for C and C++? Autocomplete while using the Zig build system. So this is our vertex buffer, and this is our vertex buffer memory. I just used the normal autocomplete for C, C++. Okay, that's strange, because like last time I tried to use VS Code with C and C++, I have to like configure clangd and all sorts of crazy things. But yeah. Alright, so let's actually try to add another buffer now. And honestly, let's try to make a struct called buffer. Honestly, and well, no, I haven't run into clang stuff yet. Yeah, that's interesting. Okay. So const buffer is equal to a struct and buffer in memory. What is that called? Vacay memory, I guess. Device memory. Okay. They added lazy pass to Zig, so yeah, it's shaping up really neatly. Yeah. I wonder if it even supports what Zig supports, like for example, just like tree shaking the whole code and like removing all the unused functions and so on. I don't think it does. I don't think. Because that would require like a lot of compiler stuff, not just a build system thing. But yeah, anyways, so that's the buffer. And we could basically, instead of doing this, we could say that this, wait, missed the question, didn't understand. I mean, so in Zig, what you have is that if you have some function, like in, let's say in a library that is not being used by your program, it just gets removed from the binary, you know? But in C and C++, that's not really the case most of the time, I guess. I think, yeah. So I think it's called tree shaking. At least I believe that's the case in React and other stuff. Tree shaking. Is that the case? Code tree shaking. Yeah, a removal of dead code is a term for dead code elimination in JavaScript, a process that removes unused code from the final application bundle to improve performance and reduce file size. But yeah. Oh, yep, I don't think it implements it or even supports it for Zig. Yes, it does. But yeah, alright, let's continue this thing right here, Vertex buffer. And let's just change the code that needs to be changed now. So instead of this, you're gonna say dot buffer is equal to buffer, dot memory is equal to memory, and there we go. You can tell your linker to do that if there is no compiler build system way. Alright, so vertex buffer, and memory. But honestly, I think we should just add that buffer creation stuff into the struct. So you know what? Fine, let's create a new file called buffer.zig and call it a day. Right. Because this is gonna be getting very complex really quickly, apparently. Fine. So let's just grab this part and buffer.zig, and it's gonna be, wait. Yeah, let's just grab the I guess just std and c, right? Or what? I think just std and vacay. Yeah, probably just std and vacay. So let's grab that and let's come here. And this is gonna be a vacay.buffer. Right, and it's gonna be like a pubfn init. Actually, let's see if Gemini could actually do this. Hold on. Let's see if Gemini could do this again. Yeah, let's recover or discard these changes. And let's see if we could do it. can you extract the buffer abstraction from here? The zig buffer abstraction. Let's see if this works. So buffer.zig, and we got this. And we're gonna remove this pub_const buffer. And there we go. And here we're gonna say self instead. So const self is equal to this. And self. I wonder if we could like make this very fast, just like depending on ChatGPT or something. Wait, I actually use ChatGPT, not Gemini. I thought I was using Gemini. Anyways, fine. So now how are we gonna use this? Let's see. Well, I guess let's just tell it to do it here. Fine, and let's see what it's gonna do. What I'm gonna change in main, or you know, let's just take this and let's go to the part where we're creating the buffer stuff. Where is it? Where is it? Buffer. Oh boy, I don't really trust in Gemini, man. Did I actually at least commit my changes? Yes, I probably did. Yep, I did. So we're fine. Lloyd. Yeah, weird. Staging.dinit. Let's just tell it to refactor this. Fine. Okay, change the original code to use the abstraction. Only showing the modified parts for clarity. Thank you, comported box is amazing. Thank you so much. Staging, map right. Okay, let's grab this part, fine. And let's go to the pipeline creation stuff. Where is it? Sorry, the buffer creation stuff. Here we go. So this whole code is for the buffer. So let's just take this here. And obviously we're gonna need the buffer abstraction now. So const buffer is equal to import buffer, well, buffer.zig. Okay, so here we initialize in a buffer, vertex size, the init. So this is the staging buffer, and we're writing to with the vertices, and then we're creating the vertex buffer in the GPU and VRAM. Yeah, there you go, device local bit, and staging.copy2, and we use the staging buffer to basically copy. Oh yeah, it's taking the command pool so we can create the command buffer. Great. And where's our buffer now? Yeah, it's called vertex buffer, obviously. And we don't need any buffer memory thing, I guess. Yeah, but the buffer should be buffer. And I guess that's it. Now let's try the other stuff. Now obviously we need to make sure to de-init the buffer here. So instead of free memory and destroy buffer, we're just gonna do self.vertexBuffer.deinit. And in the render loop, replace the binding. cmd bind vertex buffers. Fine, let's see. And hopefully this just works. So obviously it seems like we have an error already here. This should be self. And let's see, would this work? Hopefully ChatGPT. Misinstruct field buffer memory. Let's remove the buffer memory here. No field named vertex buffer instruct app. Okay, so let's actually make sure to call this vertex buffer. Hello world prints my code I do after I get bored. Let's see. No field named vertex buffer instruct app. What? Oh, I didn't save the code, I guess. There we go. Okay, so right now we have just abstracted the buffer using AI. That's sick, bro. That's sick. I didn't really... So they have basically a copy to it, allocates its own command buffer. Now this is not like the most efficient way to do it. Usually what you want to do is like you would create a big staging buffer, like kind of like a ring buffer, and you just copy to it a lot of data, like for vertex, index, and so on. But that just makes things very complicated. So this is a very simple way to do it for now. And it would work just fine for static stuff, at least, for static buffers. Map right. Yeah, that seems good for now. Okay, so now can we actually add a vertex buffer? Sorry, an index buffer now. Okay, let's use our abstraction. So index buffer is a buffer. Okay, cool. And what we're gonna do now is we're gonna create an index buffer. So, well, we could create a second staging buffer. In fact, we may need to do that. Not using AI for editing code is good. I mean, it really quickly have done it for us, so that's nice. Okay. So should we create a second staging buffer or... Wait, map right. Does it give us the offsets? I mean, there's two ways of doing this, as I said. Either create its own staging buffer. But if we can... Wait, so there's the offset here. Self.memory, map memory, offset, cell.size. Why it's in my... Oh, defer. Wait, what? Ah. I mean, let's try it. Fine, who cares? So let's give it the offset here. And we're gonna get an offset here. So the offset is usize, I guess, right? Is that the case? No, it's actually device size. Okay. So vk.device size. Okay, we got the offset there. Okay, that should work. So let's go back into our app.zig. And now in this case, we're gonna say offset is 0. Right, and then what we're gonna do next is try staging dot map right GC, and instead of vertex now we're gonna say the index, which is like, let's say U32, and the data is our indices. So right now what our vertices are, so this is our vertices, and so our indices would be let's see, so it's gonna be like a U32, wait, and here just infer the size. I'm gonna say 0, 1, 2. Nothing fancy. Does this work? I'm not sure why it doesn't want to save this now. Is there like some problem? Yeah, it's still okay, fine. So right now we're gonna say indices 0, alright, and the offset would be the vertices dot size. How are we gonna actually take that though? Like we could just say size of vertex times, or is it? Yeah, times vertices dot len. And that's the offset. So basically we want to write the indices right after the vertex data. That's basically it for the map right. Now we're gonna basically create an index buffer. There we go. And here instead of vertex buffer bit, we're gonna say index buffer bit and transfer the st bit. Alright, and then we're gonna say try staging copy to, but the copy to would also need to change, I believe. Yeah, so we need this src offset and this dst offset, I guess, isn't it? Wait. So right here what it's doing, it's creating the command buffer. Cool. Beginning the command buffer, and here we got a buffer copy. So we're copying the st. So so our buffer, the src buffer, is basically the staging buffer, which actually does need that offset. No, the dst doesn't need the offset. Yeah. So here we're just gonna have like an offset, and it's gonna be vk.device size. And there we go. And so this offset would go into src offset because we want to offset in the staging buffer. All right. Now, hopefully this would work. Let's see. So I guess 0 here, right? Yeah, that's the copy to. And right now we're going to do the exact same thing here. And this time we're going to do it for the index buffer. Oh wait, the size is the vertex size. What is the vertex size here? What? Size of type of vertices. What? Oh, so this is how you get the array size in Zig, I guess. Interesting. Very interesting. So that does mean that I don't have to actually do this. I could just do this. Yeah. That's cool. So what we're gonna do here is copy to, and do we have to do offset here maybe? Is that it? Yeah, I think so. Index buffer. No. Wait, what? Yeah. That seems, I guess it should work. Vertex size. Alright, let's just try this out. And now instead of using cmd draw, we're going to use draw elements because we're going to be using index buffer. Oh boy, this is very complex, as you can see. A lot of moving parts. What? Isn't it not called draw? Oh, draw indexed. Okay. Alright, so here we're gonna give it the command buffer, and the index count is the indices dot size or dot len, and the instance count is 1, and the first index 0, the vertex offset 0, and the first instance 0. And there we go. And what's other than that? We're binding the vertex buffers. I think we should also bind the index buffer, right? Or no? Yeah, there we go. And here we're gonna give it the command buffer, and here the buffer, which is self.index buffer, and the offset is 0. Yeah, and the index type is U32, which is uint32. And hopefully this would work. Alright, so again, we're gonna be debugging this boy. Missing struct field index buffer, yep. So let's add the index buffer here. Okay. Parameter type declared here. Expected type vk.buffer found buffer. Oh yeah. So we're gonna give it the handle. Oh, what? It does work? That's insane. But there is some validation errors. So let's see what's wrong. So the offset 0x3c plus size oversteps the total array size. Well, that doesn't seem like a good idea. Vk map memory in the size. Oh wait, the source buffer is this. Oh. I know exactly what's wrong. So the staging buffer should have the correct size. So where's the staging buffer here? There we go. So staging buffer is create buffer. So here we're saying size of type of vertices plus the size of the indices. Wait. Upload vertices. Wait, create buffer. Are we actually using this upload vertices function? Or am I tripping? No, I don't think we're using it. Wait, I'm confused right now. Yeah, we're not using this. We're using our abstraction. That's why this is not necessary anymore. I think the same thing with copy buffer, right? Yes. So let's just remove these. Okay, the other thing now. Let's go back into our staging buffer now. Okay, there you go. So try buffer.init vertex size plus the index size. Now the index size would be equal to, and in fact, did we actually? No, we didn't change it here either. Okay, so we're gonna basically say size of type of indices. The same thing we've done here. And now we could just, the staging buffer would be as big as vertex size plus the index size. And here, obviously, we're going to use the index size. And there we go. That should do the trick. And we're still getting some validation errors, so I'm probably missing something else. And hey, at least it works. But we gotta figure out what's the problem. Okay. So we have a problem in map memory. And command copy buffer is greater than the destination buffer size 60 minus. Oh boy. So that's why most tutorials actually just, creating one staging buffer for every single buffer instead of bothering with offset and so on, because it's tricky to get right. But here we got the vacate map memory. Let's see where we're mapping memory here. So we're mapping it here, I think, right? So we're saying vertices, indices, vertex size. That seems fine, but I guess let's see the logic here. Or, you know, we could do something interesting, which is in the validation, we could tell it to like break, yeah. And right now we could just zig build and just do debug, and it should break on the validation message, I think. Okay, where's the call stack? There we go. Okay, so it's right here. And in buffer.map right. So here. So what's the problem here? We're having a size of 72 and an offset of 60. Oh, wait. Oh, okay. I see. I see what's going on here. So right now it's actually mapping the whole size, but in our case we should say maybe, well, the data size. Yeah, we could use that. Instead of self.size, we could say type, well, size of, type of, and data. And now let's try again. Zig build too simply. And let's go. And now let's see where this is going. So this one right now is in the copy buffer. So I think we have fixed the first one. Okay. So let's go to the second one now. So copy buffer. Oh, this is in the copy to function. So we're trying to copy from the staging buffer up to whichever this destination buffer is, which is actually of size 60. Of size 60, and here's 72. Oh, again, here we're using self.size again. Oh, man. Okay. So let's stop that. And instead of self.size, we're going to use destination buffer size. Now, actually not... Do we even have size there? Wait. Yes, I think we do, apparently. So let's try again now. So zig build. And boom. So we fixed those issues. All right. So basically why I'm doing all this, oh boy. We forgot to actually like destroy the buffers and so on. But basically what I've done here, what I was wrestling with is, so instead of having like one single staging buffer for every single other like VRAM buffer, like vertices and indices, right now we only have one staging buffer, and you just too simply write into it the vertices and the indices. And yeah, that's basically it. And then you copy two. Now honestly, it could have been better if we have this kind of like operations merged together in one command buffer, but right now let's keep things simple, because what the heck. All right, cool. In fact, we could even ask ChatGPT about this change. So I made it work with one buffer using offset. Yeah, I forgot about that part. Let's fix that. So where we got that? Destroy command pool. Okay, vertex buffer.dinit. So self.indexBuffer.dinit self.jc. Yeah. Right now you do, this works by luck, but Vulkan requires alignment. Yeah, this sucks. Problem, vertex 4-byte aligned, U32 4-byte aligned, fine here, but in general, uniform storage buffers, etc. this will break. Fix robust version, add alignment helper, align forward. Or better use device limits. And vertex offset index, then bind like. Okay, vertex, you did this very cleanly. Correct spoken usage efficient stage in abstraction proven, generally just missing index buffer dinit, alignment safety. Yeah, okay, let's just copy this align forward. You having problems with alignment on which side? It's just because right now I'm writing the staging, the data to the staging buffer directly. I have to basically take into account alignment. And that's basically it. So let's see what we got. Now, honestly, I would even like to really make like an apploid buffer thing, but oh man. Okay. So I think we gotta put this here, right? Align forward. And what's we gonna do next? So this would basically take the value and like align it to the next, let's say 64 or 32 or whichever. And here we say vertex offset is equal to 0 and the index offset is align forward, vertex size 4. So it's aligning it to 4 bytes. And then the total size is, oh, index offset plus index size. Yeah, I see. But a vertex offset here. Okay, fine. Let's see where we're actually doing that stuff. So here. So vertex offset, index offset. Vertex size, and here index size. Cool. So the total size here, which basically takes into account the alignment, and the vertex offset, we gotta use it here, which is basically just 0 right now, and the index offset, which we should use here, and it's aligned to 4 bytes. And yeah, that should work the same way, but just a little bit better with alignment. So zig build run. And yeah, I have no errors, so that's sick. Should we work on like a buffer abstraction, or I guess no. I'm so lazy, goddamn. But let's actually ask ChatGPT and see what it's gonna say. Can you make an apploid stage build abstraction? I got this name actually inspired from WGPU. So they have this WGPU staging build, which is very useful for like uploading data to the GPU VRAM, and it's in WGPU util. So it efficiently performs many buffer writes by sharing or using temporary buffers. I wonder if we could even like, you know, take the source and like feed it to the AI and hack the system. Oh boy. Because honestly, I really don't trust the AI with all this business. So yeah, honestly, let's do that. Let's do that. Hey, let's see. Okay, so I'm gonna copy this whole thing. Inspired from WGPU. Yeah, this is too much for now. But let's just see what it's gonna do. WGPU uses async mapping. Vulkan must track fences yourself. Check fence. Ah, no. No. Yeah, no. Let's not go that way. For now. Yeah. Actually, it's much more crazier than I thought. It's actually more than just like an offset, apparently, for some reason. Yeah, let's not go that way for now. It's too much. It's too much, yeah. Anyways, let's actually try to get some textures working. Let's try to get some texture working. I have no clue where to even start with that, but let's see. So first of all, I think the new SDL3 have a way to like natively load PNGs. So I guess let's start there. But we need some image. So I don't know what image to use. I mean, honestly, we could just take a screenshot of this and just use that as the texture. Fine. So the texture has been copied to the clipboard. Or actually, let's work on the 3D as I said, because this is why we actually added the indices and so on. Yep. Let's work on the 3D first, maybe. Although I'm not entirely sure what like Zig math library I'm gonna use. Yeah, but anyways, let's just ask the the ChatGPT to generate this stuff. Change this to a cube. What a time to be alive. There we go. Let's try now. And we have a problem. Expected to array elements found 3. Oh, wait. Before that, we gotta adapt our code to be 3D. Okay, wait a second. So instead of here, we got the position. So we're gonna say 3. And also, we don't need colors, or do we? Right, so let's change this first of all to B32, and honestly I really don't want colors, but we could change that later on for texture UVs and so on. Yeah, we could change that to texture UVs later, so let's keep it. So RGB32, pause color, cool, and right now it's just basically zeros. Okay, cool. And but wait, I should probably change right now the shader, right? And this is gonna be a little bit annoying. So right now this should be this, and it should be vector 3. And what else? Triangle frag. V color, F color. Okay, that's cool. So let's actually make a little script, I guess, here or something. Or you know what? Let's investigate how we could, you know, like auto-compile the shaders, hopefully. Can I auto-compile shaders in Zig build system? Using the command glslc. Is add system command. So you just say add system command glslc shader slash, make sure it's built before your exe. Ooh, output into Zig cache. Oh boy. Yeah, that's pretty interesting. Why not loop through all files in a directory? Okay, let's start from this code and let's see if it have no errors. Then call it add shader compilation. New files won't trigger rebuild automatically, which is fine in practice. This line won't work directly. Should do. I mean, let's see if it works even in the first place. Fine, so what we're doing here, we're opening directory shaders, where in the current working directory, which is basically this. So this shaders, I guess, should be here then. Wait, what happened there? Okay, there we go. But how are we gonna make the embed things work? So here we iterate through all the files, and like while it next catch unreachable entry. If entry kind not equal to a file, then continue. So the entry.name only compile GLSL files. So if not, std.mem ends with vert or frag. So let's remove this and remove SPVs right here. Triangle.frag and triangle.vert. And now here b.path join the shaders, comma name, and b.cache root, comma name plus .spv. And then add the system command glslc input path. Yep, that seems perfect actually. But so it's putting it in the cache, but how I'm gonna embed the files from the cache? Can't directly from Zig at runtime because it runs at compile time. Into a known table inside your project and then embed that path. Okay, so no, the Zig cache part doesn't work, so we're gonna use this one instead apparently. Okay, ouch path is this and ouch path. But wait, Zig ouch. Well, embed only works with files inside src, I think. Okay, so alright, fine. So does this even work now? So it's gonna put it in zig-ouch. Okay, let's try. So zig build, but first of all, let's add it here. So b.add shader compilation, or actually no, add shader compilation b, and here the exe, which is, well, our exe. And zig build. Enable to resolve comp time value. Yep, it says something about it. I'm not sure why I didn't do it like directly. Yeah, well, wait, what it's doing here? Instead of embedding, just load at runtime. What? Read file alloc. Embed them in Zig. Anyways, where's that thing? Here we go. You should do out name. Alright, let's do this. And let's give it out name. And failure. Why? No such file or directory. Yep, you gotta make sure to probably make the directory shaders, zig-out/shaders. So let's see how we could do that. std.fs.cwd. Maybe make there or something, or make path. Probably make path, I would guess. Yeah, there we go. And the subpath would be zig-out/shaders. And there we go. Now make path could return an error, so we're gonna say try. Expected type void. What? Oh. Catch unreachable. Oh, that's weird. Why did that? Let's just say try here. Whoops, try. And here try. Here try. And yeah, I guess that's it. So we did it here too. That's stupid. Okay, so expected type void. Yep. Oh, wait. Does this actually can't do it? What if I do this? Does it even work? Oh, we do have a shaders directory. Enable to open. Yeah, so right now let's just fix the embed files. So let's go back into our app.zig and where we're actually doing the shader stuff. There we go. So instead of this, we're gonna say, I guess, zig-out/shaders. No? Or we could say // okay, // yeah. There we go. So ChatGPT sucked there. It said that you can, but you can't. So you know, we could even like generate it in SRC. Yeah, I think so. Man, come on. Yeah, see ya later, mucho. Thank you for coming. See ya. Build steps modify non-reproducible builds. Use add anonymous import and then import it. What? Should we try runtime loading? Important Vulkan detail must be aligned to. Okay, I guess PubFN Lloyd shader. So let's see if this would work. Did I actually like save this stuff? Oh my god, I haven't. Damn. So wait. Before we do something strange here, can we just like at least add this part? So wait. Let's go to build.zig and let's just copy this whole code. Let's grab a file really quickly and just paste all of this stuff here. Let's first of all stage the changes that we've added. So here it actually works, right? Like zig build run. Yeah, wait, let's, where we're doing the shaders here. So let's just revert the block. And let's try. Well, enable to open shaders triangle file not found. Okay, let's just discard the changes, restore the file, restore the file, restore the file. And okay, so that works. So I'm just gonna take this whole thing Can we just remove this shader compilation part for now? So we just have, here we added the buffers, right? Yeah, we added alignments. Yeah, I forgot about that part. Okay, so let's just stage all this and buffer abstraction, I guess. And let's commit. Sync changes, okay. And we're good. So now let's go back into that stuff that we were trying to do. Just cancel. Let's go to build.zig now. Let's take it back. And so what we got now? Alright, so we got this. So what we were doing in app.zig, right? Yeah, we were trying to basically load those files at runtime first. Yeah, actually, so this is too much, wait. Oh boy. My brain is fried. Embed file. Yeah, let's actually try to load that. Fine. Where is that? There we go. Let's see if this would work. Load the shader. So it's opening the file, closing it. You're getting the impulse, allocating a buffer enough. Is there no like file read alloc? No? To end alloc. There we go. So I'm not sure why it's not trying to use it. Max bytes is... Huh. Max bytes. That's strange. Can we just say size? And that's the buffer, I guess. And try this. And defer. Well, actually not defer. Yeah, that's fine. And we're good. It's never mutated fine, so let's say const. Deprecated in favor of reader. Damn. Okay, so we gotta use the reader. How are we gonna do that? how do you even use a reader? I forgot completely. So like you say file.reader, right? Yeah, and you give it like a buffer. And the buffer would be, you know what? I think I'm gonna scrap this idea for now. Yeah, I'm gonna scrap this idea for now. Let's just not go with this for now. It's fine. Whichever we have right now, it works. If it works, don't touch it. Goddamn. So fine. Let's just remove this extra stuff now. Discard, discard. Really, that sucks. Don't save, and we're good. Okay, so far we have this working. Okay, cool. So what we're gonna work on now? So we wanted to basically change the shaders. Yeah, we want to change shaders. So I did change them, but right now I'm just gonna recompile them essentially. So glslc, yeah, I'm just gonna create like a very regular script, pretty much. So shaders slash triangle vert dash o src slash shaders slash triangle dot vert dot spv. And in fact, you know what we could do is we could create another folder here called shaders. Oh, we already have one. And it would just contain only the source code. Cool. So instead of src shaders, we're gonna say shaders slash triangle.vert, but the actual binary would be inside of src for the embedding part. So can we just remove all of this? And let's try this. And there we go, cool. Next up is, so I'm just gonna copy this whole command. I'm gonna actually make a script here. Compile shaders, very simple. Compile shaders, we're gonna do this, and we're gonna do that shebang. So shebang slash bin slash sh, or bash. I mean, it doesn't matter, I guess. Let's go with bash, fine. And right here, we're gonna do copy that and paste it here. Instead of vert, you can go with frag and frag, and we're good. So right now, we're gonna do chmod plus x and compile shaders. Compile shaders, and boom. All right, so right now we have both. Cool. Very simple. No Zig build system stuff, no nothing. Oh man, that was insane. Anyways, so I think this works, right? Yes, this works. All right, so where we was right now, so we changed this to 3D. Now can we actually do a cube? Fine, let's do a cube. Generate a cube instead of a triangle. Oh my god, I butchered that, but yeah. I wonder if Zig have OBJ, so maybe we should look into that. Or we could even like use a C library for that, but yeah. Honestly, that could be an interesting way. Yeah, that could be an interesting one to do. The contents of the file is newer. What the heck? Overwrite. Let's try Zig build run now. And what's up? In declared identifier. Oh, wait, no. What? Yeah, let's just remove this Lloyd shader code. Okay, so right now we got a cube, I think. Although it doesn't look like a cube because, you know, it's not rotated pretty much. But can we actually rotate it? Well, we're gonna do that by too simply having a camera, but we need to look out for some. Is there a Zig math library. Z-math. Zig game dev, Z-math. And ZLM. For graphics. Okay. So it was 6 months ago, so I'm not sure if that's a good thing. Upgrade to Zig 0.15.1. So it's a SIMD math library for game developers. Just on provides. Documentation can be found here. Okay, what are our other options right now? Alternative ZLM. Okay, so there's also ZLM. Zig. Zig linear mathematics. Current the following provides the following types. And 4 months ago. 269 stars. This one, 92 stars. What? Okay, which Zig version this is using? This seems very bad. Yeah. You know what we could do? Let's go to Zig. And let's ask people. What do you guys recommend for Zig math? Like GLM. Other than that, yeah, let's see what people would say. Hopefully there's someone. It doesn't seem like there's anyone for now. Interestingly. There's even ZM. Did we actually look into this one? ZM, move to Codeberg. So this one is just 2 weeks ago, which is good, at least. ZM. But this is only for 0.16 apparently. Yeah, this is only I guess for 0.16. There's no compatibility branch. So we can't really use this. So this is out of the equation already. I mean, there was like some package which contained all sorts of things for Zig. So like, in fact, we could also do another thing, which is to go to Discord and search for GLM. So really, there is no good Zig library for math just yet. Should we really do our own? Damn. I mean, I guess that would be better off like in another stream. Is there a library similar to GLM for Zig? Zmath? Yeah, this is a lot of problems, bro. Did anyone have like said something? Let's see. Z-algebra served me well. Ooh. Does it work for graphics APIs like Vulkan? Have you tried the rest? Like Zmath and ZLM. Issues. Oh, it doesn't support column major? Yeah, that doesn't look great at all. So the other guy said Z-algebra. Let's see what this one. Well, GitHub, Z-algebra. I only tried Z-algebra, used it for a month with OpenGL and Vulkan. You will need to update perspective orthogonal methods to match your expected coordinate output, but I think it works out of the book for OpenGL. Yeah, that's gonna be a lot of trouble, but the main branch is for the latest Zig release 0.15.1, so that's fine. Okay, this seems nice. This one seems nice. Alright, I guess let's try already. I mean, someone have recommended it. I currently use my own build library tailored to my own project. I see, thanks. Okay. Okay. Right, so how do you actually download this now? I wish if we added like that, but anyways, we could probably say zig fetch, yeah, save, and let's remove this GitHub URL and add this one. Okay, and let's try it out. So build.zig, and now we're just gonna do simply like copy one of these, or just do it ourselves, fine. Let's just say const, and like, what is that called? Z-algebra. So like Z-algebra dep is p.dependency, and here's Z-algebra, and args target is equal target, the optimize is equal to optimize. And yeah, now I'm gonna say xc.root module dot add import Z-algebra, and the module is Z-algebra dep dot, I guess, dot module Z-algebra maybe. Now let's try it out if it's gonna work or not. So zig build. Okay, so far we're good. Now what if we try to say const Z-algebra or ZLA, I guess. Actually no, Z-algebra. Zag. ZA. Anyways, let's just do this. Import Z-algebra. And let's see if this works or not. So if we say ZAL dot, and it doesn't really give me anything. No module named Z-algebra. Okay. ZA. Okay, cool. ZA, Z-algebra. Is there like an example here? Okay. It does have a build.zig. Where's the... Yeah, there we go. Well, this is exactly, I think, what I've done here. But let's just copy it either way, just to make sure we're not missing anything. And then what you've done is src main.zig const za. Okay, so it works. Alright, that's sick. Now let's start by trying to at least what can I say? Let's try to use it for the vertices here. So what we're doing currently, we're just using an array, but can we just, I wonder, so it is using extern struct, which is sick, I guess. That would probably work, I guess. You know, let's ask ChatGPT really quickly to give us a rough idea. Okay. Would this work with Vulkan? No, this is just a Vulkan thing, not like the problem with the library. And we could even use a scalar layout if we really want to. I think it should work because it's extern, so oh, but this is a little bit of an issue, that's for sure. Wait. Yeah, I haven't actually thought about alignment. Because like before, I think... converge when uploading. That's weird, but you know what? You know, let's just try this. Fine, who cares? Anyways, let's try this. So what we're gonna do is VIC3. So VIC3 is of F32, right? Yep, it is. So we're gonna use VIC3 here, and we're gonna use VIC3 here. You know, sometimes instead of overthinking it, you just go ahead and do it. Right? So yeah. And I wonder right now if this would work. So let's see Zig build. And we have a little error type generic does not support array initialization syntax. Okay, so what does it support instead? I guess maybe init or something? I mean, let's see the example again. So how do you do that? .new or yes? Yeah, it seems like .new. Alright, so I'm gonna do a little trick right here. I'm gonna give the AI this. And I'm gonna tell it to convert this into using VIC3. Yep, there you go. And we could just steal this, put it here, and we're good to go. Alright, so this is what AI is made of. Zig build, and boom. Nice. Now would this work? It seems to be working. Great. Lovely, it worked. And also another thing is, since we're using this now, offset off. Yeah, that's good. So what I wanted now, anyways, this is good. Alright, so let's go to the next step now. So we want a camera. How are we gonna do a camera? So let's try to do this quick. Triangle search. Add a uniform for camera. So match for MVP. And then we just do times that. Okay, so that's the updated Vertex shader. Cool. And what this does, project I know anyways. This matches your Zig code. Import Vulkan detail. Wait, what? No, mat4 should be fine, I guess. Anyways, so can we just use a mat4? So right now we're gonna try to use what is it called? So let's try first of all to compile the shaders. Cool. And yeah, let's try to use the push descriptors right now. Let's see how it's being used. So here, bind vertex buffers and stuff. So what we're gonna do instead, say self.gc dot dev.cmd push descriptor, right? Just descriptor set, I think so. Yeah, and here the command buffer, here the pipeline bind point, which is graphics, and the layout. I think we already got the self.pipeline layout, right? Yep, and here the set. The set, huh? So I don't remember what I should use for this, but let's just say 0 for now. The scripture write count, I guess 1, and write the scripture set. Write the scripture set. So let's just say ptr cast and write the scripture set. How are we gonna do that one? Write the scripture set. And here say several things. Let's actually ask it. How are we gonna use vkcmd push the scripture set? We already enabled the extension in the first episode, like the first stream, so we're fine. Your layout still exists. Layout binding, uniform buffer. Yeah, we gotta create a uniform buffer. And same as usual, just include the layout. Okay. Descriptor set layout create info. I mean, let's see if this would actually work. So basically, let's just comment this out for a second. And where are we gonna do this? In the pipeline layout create info. Boy. Where we're creating that? Here. And we could just paste this, I guess. And this is the right type, cool. And I don't think this is part of the scripture set layout. Create flags, right? Bro, what? There you go. And here we choose simply set the push the scripture bit, okay, to true. I have no clue how I'm still like having a sane mind writing all this. So, oh man, if I overthink this, I would have never done this, bro. Anyways, the scripture set layout binding, because who in their right mind would do would do Vulkan in Zig, bro? Oh boy. Anyways, binding equal to 0, and here the descriptor type is a uniform buffer. Cool. Descriptor count 1, stage flags, a vertex. Okay, sick. Everything's good so far. Alright, and here the pipeline layout create info. We're just gonna add this. Cool. Let's see if this works. Set layout count. Cool. And pset layouts is this descriptor set layout. Where is the descriptor set layout? I guess we gotta create it. So descriptor set layout is equal to try gc .dev.create descriptor set layout. Descriptor set layout create info. And here null. Okay, and let's see what we got here. So we got the binding count, the flags, the p bindings, the binding count. Wait, well, this is exactly the layout info that we want, right? Yeah, gotcha. Okay, so let's just grab this and let's put it here. There we go. So binding 0, descriptor type uniform buffer. Okay, so that works. That works. Oh, what the heck did I do here? I guess just vacate.descriptors. Yeah, that works. Alright, so let's try to use this one. Yeah, it's being used here. And so far, I guess we're good. Is there like some error or something? No, at least not yet. Anyways, so your camera buffer, we probably need to create like a descriptor. Wait, descriptor MVP. So just a mat 4. Okay, let's create a uniform buffer. I think that's probably what we want here. Okay, so how are we gonna do this? So let's just copy one of these and let's call it a uniform buffer. And instead of the index buffer bit, we're gonna go with uniform buffer bit here, and it's gonna be device local, so basically in the VRAM. And here the size is the uniform size, and the uniform size would be uniform size. Well, let's actually take it here. So const is equal to size of, and size of what? Yeah, we're just gonna give it mat 4. So matrix 4, right? So what is matrix 4? It's just like an array pretty much, so that's cool. Alright, now next up we're gonna need const uniform offset, I think. And let's just, I guess, use align forward again, maybe. And for that, so here we're using vertex size. But the uniform offset should be index offset, probably, plus uniform size. And the alignment, I guess, let's go with 4 maybe. And we're good. Now here we're just gonna do this. And instead of indices, we're gonna create a mat 4. So mat 4. Oh wait, would this actually work with a... We probably need to make a slice. Yes, pretty much. Fine, that's fine. So we could just say mat 4, and then here try to make some sort of a slice. So we're gonna say, I don't know, let's say, I guess cameras or whichever, and equal to, so basically an array of mat 4s. Is that the trick here? And well, actually let's use the what? So this should actually be the type, right? So let's go with that. And what are we gonna do here? You know, let's just create one camera first. So the camera would be mat 4 dot new, I guess, or something. No? How are we gonna create the camera? I guess we could maybe use look at, but that would only... Oh, we gotta construct the MVP. So MVP would basically take in... You know what? Let's just tell the AI to do this. Fine. Can you create the MVP? It's in Z-algebra. Okay, let's grab this code. And fine, let's keep it as a function for now. So make MVP, it's using ZA.perspective. Cool. the aspect ratio though. This needs to take into account the size. Yeah, but for now let's keep it hard-coded. Z.lookat, so the camera position, the target, the app direction, the model here from translate, map model. Alright, so that's sick. So that would give me the MVP. Great. Later on we could make it more sophisticated, but for now they should be fine. So here what we're gonna do is const MVP is equal to make MVP. And here we kind of like need to basically turn it into a slice somehow. Can we actually just say MVP like this? And we may need to like PTR cast it or something, but this should be fine, I guess, for now. And other than that, yeah, that seems fine for now. Okay. Or we could maybe do this. Yeah, maybe this. Like dodge. Alright, cool. So what we're gonna do next now. Now instead of index offset here, we're gonna use the, what is it called? The uniform offset. Okay, cool. Now we gotta also make sure to copy to the buffer. So here we're gonna say vertex size. Oh crap, what? It's using vertex size. Oh, why we're using vertex size here? That's crazy. Vertex size. Okay, for now can we just do plus uniform size or index size? Yeah, for now let's just do it this way. Okay, and I think that should work. Other than that, I think we're good. Oh man, this is so complex. Descriptors set layout. Alright. Okay, what else? Important Vulkan correction. You must flip the Y in the projection matrix. Okay. So let's go to the projection and let's flip the Y. And so full version is this. Yeah, let's just make sure that this works. Okay, we'll have to send it to shader, to options, push constants, recommended. I mean, honestly, push constants would be even faster, not gonna lie. You know what? Since we already started this anyways, let's just continue with the push descriptors and hope for the best. So yeah, push descriptors at draw time. Your camera buffer, cool. And here what we got. Okay, let's just copy this code and see what the heck is going on there. So where we're doing the CMD stuff. So like vacate CMD, wait. Bruh, draw, there we go. So let's try this out. So we got this. And here we're gonna need like some sort of a buffer, which is basically our uniform buffer. And the size of, well, match 4. The offset is 0. The destination bind is 0. The descriptor count 1. And descriptor type uniform buffer, cool. And here we gotta say this. Well, just this. And here the command buffer, so cmd buff. And here the pipeline layout. There you go. The set index 0. Cool. That seems good. That seems good. So let's just make sure to add this uniform buffer. Oh my god. That burnt out would be quite insane. Anyways, buffer. I'm gonna try to keep going anyway. So uniform buffer, there we go. And let's go. Where is the uniform buffer? So it's right here, but we gotta add it. So dot uniform buffer is equal to uniform buffer. And there we go. So do we need anything else? I think that's it. So push the descriptors at draw time. Yeah, I think so. Yep. So time for the truth right now. Does this even work? Probably a lot of errors first of all. So let's hope for the best. Okay. Now has no member named Vertex. Shader stage flags. Huh. Wait, what? What? Shader stage flags. So vk.shader stage flags. Yeah, I think we gotta do this instead. Yeah, pretty much. There we go. That's the first one. Second one is this. So this is problematic. Index 5 outside array of length 4. I mean, I actually did give it like the actual source code of the matrix, so I'm not sure why it did a problem there. Bruh. Okay, where's the matrix type? ZA perspective self. Whoops, not that one. Not that, no, not that one. Wait, here we go. Here we go. And there you go. You want to flip the 1 element, the Y schedule projection. Yeah, that makes sense. That makes sense. Okay, but anyways, let's try this. And boom, zig build run. And here, there we go. Can we just say PTR cast for this one? Expected type vk buffer, sure. Let's say dot buffer. Came a long way. Expected type. Yeah, can we do PTR cast again? Debugging a bug here would be a nightmare, bro. Hopefully we wouldn't get that. Alright, so anyways, so we're pretty much just like, what is that called? I really forgot the name, man. Anyways, let's just continue. So DST array element and DST set and bimage info. What does that even mean? So we're trying to write some descriptor set, and we got the destination binding is 0, the descriptor count is 1, descriptor type, the buffer info, and destination array element. I mean, I would guess it's probably 0. And here the destination set is 0. And pimage info, ptexel buffer view. I don't even remember these existing. What the heck? Descriptor image info. We don't have an. Wait, no. This should be null, right? Is this a pointer? Yes, it is a pointer, so yeah, we could go with that. I don't think, because we don't have an image here. Yeah, that's pretty much it, I guess. Zig build run. Now DST set. Oh, descriptor set. So I guess self.descriptor set. Obviously. So let's add a descriptor set here. I don't know where to put it, so let's just put it wherever. vk.descriptor set. There we go. And let's try to add it here. Dot descriptor set is equal to descriptor set layout. Is that the case? Really? Wait, what? Wait, what? Descriptor set layout. Don't we already have like a descriptor set layout? Bruh. So let's actually just change this at least to descriptor set layout, and let's figure out the descriptor set. Cause what the heck is this? Descriptor set layout. So let's change this to descriptor set layout because we're gonna need it maybe later on. Who knows? And let's go back to right. Where are we gonna get this descriptor? So we only have the layout. I'm probably asking a dumb question, but let's see. Ain't no way. I mean, I've done this to actually like avoid the descriptor pool stuff, man. Correct push descriptor right. Oh, should I just like keep it empty? Yeah, I think so. Ah, man. Okay, so they're basically sharing the same kind of, I guess, the same struct. 0. And I guess, should we say null here or something? The null handle? Probably. Well, pnex no. And here, null. So like this. Bro, what? You know, let's just try it. Let's just try it. Expected type buffer info. Let's ptr cast this. Buffer info. Let's go. Expected type found type of null. What? Expected type. That's weird. It's really weird. P image info. Bro, what? That's insane. Something strange going on here, but okay. Well, this is supposed to be as. Well, I guess just better PTR cast. Let's try that. PTR cast. Oh boy, this is a marathon. Expected pointer type found. This is very weird. Like, what? I'm so confused. How about we do like an image info here of type, what is it called again? Descriptor image info. Right, and we just say image info. How about that? Same thing with buffer view. And actually, wait, there should be a pointer. And now buffer view. Oh wait, I think for that to work, it should be optional, right? Yeah, I think so. I think it should be optional for that to work. Yeah. So I guess you can't use that or what? I'm also making a Linux distro called Debian, and the install is not apt, it's crap. Is that a real project you're working on? You can like send me the link. Boy, that's insane. Yeah, I gotcha, but like, but I can't ignore it, nor can I set it to null, because it is not optional. It's probably something dumb. Bro, what? This looks super hacky. Is this like a problem with the binding or something? Cause what? You know, whichever works. Let's try that. Although that's very strange, but okay. Yeah, does not allow address 0. Can't hack the system. Oh. Yikes. Well, that's also a solution. Okay, fine. Whatever. It's probably an issue with the binding, I would guess. Because that should be optional. But Let's try this. Bruh. I can't believe I'm stuck on this issue for like, I don't know how much. Oh man, I have to like, what? Can we just say vacate.descriptor image info and just say indefined, please? Because we really do not care what's the content of this. We just want to trick the type system here. Ah, boy. Yeah, whichever, bro. Next. Okay, so root vacate pipeline. Yeah, can we just see the graphics here? Okay. I'd be pissed if this doesn't work. Oh man. Expected type, sure. I mean, I guess we just gotta go with it until the end and see what happens. And boom, we have some error. Okay, did we add the uniform size into the staging buffer? I could already tell that could be the issue. Totals, yeah, no, I didn't. So index offset plus index size. So instead of that, we could say uniform offset plus uniform size. And we still have a problem. So it's greater than the source buffer size minus the source offset. What? Let's try to debug this, bruh. Okay, so this happens in copy 2. Copy buffer. In here. Okay, let's see. So buffer copy 2. You can send it to me in Discord. I'll have a look into it later on. Okay, so what's the problem here? So the source buffer size is basically the staging buffer, right? Yeah, so it's 384, which I guess is probably correct. Yep, the uniform offset is basically 320. And yeah, okay. And what's the problem? Mine's SRC offset 256. 144. Ooh. So what does it give? Wait, calculator. So 384 minus 256. 128. Okay, but it's looking for 144 for some reason. The size, p region 0.size. Okay. Where is the p region size? Here. So the destination size is 144. Okay. Yeah, you know what? I think I may just remove all this offset bullcrap and just like make a staging buffer for every single one of them to avoid all this, you know, offsetting problems getting in my way every time. But let's just give it a little proofread really quickly and see if there is some obvious issue here. So vertex size, index size, uniform size, great. And we have here match for MVP, the uniform offset, the index offset, and the vertex offset. Now the index offset is aligned forward vertex size, 4. And here the uniform offset is the index offset plus the uniform size. You know, we could even just make this total size bigger for now, maybe. Would that solve the issue by any chance? This is just a temporary solution, but if it works... Oh, it didn't. Well, wait. No. Zig build run. A what? Okay, so that does work, but we're not seeing anything. So, well, could it be a problem with calling by any chance? Back bit. Let's say false, I guess, so it doesn't call it. No. Okay, let's see ChatGPT really quickly here, because this is getting out of hand. Let's see. Oh, did I actually forgot to... Wait, no way. So, I ignored the simplest thing that could go wrong. I just assumed I wouldn't make that mistake. And I've gone... Because the thing is, I had a suspicion that I could be doing these calculations wrong, so I only focused on this part. I didn't see this easier part that I could be just... man. Alright, let's just say uniform buffer. Oh my god, bro. Oh boy. Okay, but even when I change this uniform buffer, it's still problematic. Wow. That's weird. Well, you know what? Let's just copy this and see for ourselves. That's likely, but because your offset was wrong, boom. Uniform offset. Oh boy, okay. So we got something working now. Great. Is the colon still problematic, by the way? Actually, I don't have colon, so that's nice. So it does work. That's pretty sick. This seems working. But I'm not sure what I'm looking at. Okay. Or, you know what? I guess this is the time for RenderDoc. So RenderDoc. Oh man, I remember that RenderDoc had issues with Wayland, cause wow, man, I don't think it would work unless if they fixed it. My god. Unless if I could force maybe SDL to use X11 maybe, and if that would work. Use Ubuntu. I'm not sure. Ubuntu usually have like old packages, which kind of suck for development, to be honest, especially if you're working with a very like fast moving language like Zig. But yeah, I'm not sure though. I don't know much about Ubuntu, but to be honest with you, I don't really find it very good, even for beginners. Like for me as a beginner, when I just start trying to use Linux, so I have an NVIDIA GPU, and I had nightmares with Wayland and so on, with all sorts of distros, until I found Manjaro. Manjaro just kind of like fixed it. It just worked out of the box. But then later on, it kind of sucked for whichever reason after some updates. And right now, I just use CachyOS, which also works out of the box with NVIDIA. Though I did learn some fixes on even like Arch Linux, like raw Arch Linux, and even what is it called, NixOS. But man, that's a lot of, you know, fixes and so on. It just sucks. But like CachyOS, I love it. It just comes with all the tools installed. It comes with a good terminal, good everything, and it's so fast. So yeah. Yeah, but I have a high-end PC, but after a year, but I updated my OS. Yeah, I really recommend, if you'd like to try CachyOS, it's so good. It's what I use right now. But yeah. You build vertices, positions, plus colors, indices, triangles. Because honestly, people say that like Ubuntu is beginner friendly and Arch is not. But I actually found the opposite, the exact opposite when I just started using Linux, you know, years ago. But yeah, unless if you have a laptop, then yeah, Ubuntu would probably just work out of the box. Or if you have maybe an AMD GPU, then you could use any other distro. But for NVIDIA at least, oh boy. Anyways, so this matrix, anyways, so we build the vertices, we build the indices, and we got the MVP matrix. Now we do gotta actually configure right now the depth buffer. But I'm just trying to make sense first of all of what's going on there. Though, you know what we could do right now? We could try to update the descriptors so we could like rotate the cube and see what's kind of trying to make sense of what's going on there at least. Even though we don't have like a depth buffer yet. But we'll see. You copy into GPU buffers during draw. This is the key moment. Oh yeah, so I installed RenderDoc, right? Cool. So let's try to use it, and hopefully it works with Wayland. Okay, gotcha. So let's make sure to actually disable the, you know, the validation layers and so on. And let's try this out, because if this works, we can actually exactly see what's going on. Okay, so how are we gonna do this? Bin, go to check.zig vk, copy path or relative path. Let's copy path, and let's come here, executable path. Here we go. The working directory, I don't think it matters. And yeah, launch, and we're getting nothing. Yeah, I think probably because of that Wayland stuff. It's not giving me any kind of error or anything. which really suck. What can I do? Well, I guess let's create a new ChatGPT chat right now, and let's ask. Alright, let's see. So RenderDoc, I guess, have problems with Wayland. Can I force SDL to maybe use X11 and then it would work or something? Yeah, so we could say this. Hopefully this works. Yes. Much? Well, at least we get a window to pop up though. So that's cool. But something's going weird here. Yeah, I see comported box. Check what SDL is using. Well, at least with X11, a window seems to pop up, but it disappears immediately. It sucks that doesn't even give me like errors. Okay, let's grab this and let's do RenderDoc. Oh, wait, I don't have access to it or what? But I could do RenderDoc command. Okay, let's try that. Copy the path. Okay. So RenderDoc CMD capture, okay. Okay. So as you can see, when you launch it with Wayland, this is what you get, like an error like this. But okay, how can I set right now the environment variable? The SDL driver thing, so here we go. Wait a second, are we actually using like... Yeah, actually, I think we do. Wait. So if I do this... Alright, so now it seems we have another problem. Extension not present. Yeah, I see what's going on here, I think. So probably SDL is giving us the Wayland extension, although it's running X11. Well, this sucks. So I don't think RenderDoc is working in Wayland, unfortunately. Damn. And it's still open. My god, many Unix are in the process of adopting the more modern. Oh my. Yeah, this is a pain in the ass. And RenderDoc is very important for debugging, man. Debugging graphics applications. Oh, running RenderDoc itself in X11? Really? Is it called QRenderDoc in fact? Yeah, it is. Okay. So if I say this, QRenderDoc. Wait, no way. Is the configurator still on? That would suck. Let's just make sure that it's disabled. And for some reason it just like crashed. What the hell? Oh, here we go. No. There's actually multiple of them, or what? Oh my god, this sucks. No. No Vulkan executable. And let's just try to quit this for now. Let's try. Okay, now. That's strange. I mean, I disabled it, bro. That's weird. Anyways, let's just try this out anyway. Oh boy. Copy path. Let's go here, executable path, launch. Yeah, I give up, bro. This is insane. Any chance to add this to the normal build? Yeah, this sucks. It just doesn't work. Whatever. Damn. We tried. This sucks. So how do I... Let's just delete this, I guess, and we're good. And I'm not sure why my computer is going crazy right now. Anyway, so what we were doing now, my god. Okay, let's go back to this. I mean, actually, you know what? Let's do zig build run and let's just screenshot this and give it here. It's a projected mesh without depth testing, so everything collapses visually into one blended shape. But no depth buffer, no depth test. So triangles are rendered in draw order, not by distance. The key missing piece, depth buffer. So does it seem to be working well, other than the depth buffer part? Or should I say as intended? Okay, so that's sick. So I think I'll just gonna end the stream for now. And we're gonna be implementing depth buffer maybe in the next video, I think. And hopefully I could like investigate more this issue of like Zig math library and other libraries like OBJ and so on, and also I could look into you know, RenderDoc or some other solution. Remove MVP, you should see flag cube, remove camera. Anyways, so I think I'm just gonna commit this code for now. So yeah. So we added Z-algebra today. We added some uniform buffer, descriptor set layout, and we even used descriptor push descriptors. So that's sick. Uniform offset. We even implemented this one staging buffer that contains multiple data, which is actually quite advanced. Not really advanced, but you know, usually tutorials, basic like Vulkan tutorials doesn't do this. Anyways, create descriptor set layout. Yeah, that was an insane stream today. Yeah, so that was it. All right, so let's just add all this. First iteration of 3D camera, because we still have to fix some things like, you know, depth buffer and so on. But other than that, we should be good to go, I think. Commit and sync the changes. Okay. And we're good to go. All right. Boom. Cool. Love that. Alright, so that was it guys for this stream. Thank you all for coming and thanks you for composed box is amazing. You could send me the link of whichever you're working on Discord. You could like join my Discord server down in the description below. Thanks for Mucho and Arid Hanush. And who's else? And Craft Ramzan. Thank you all for coming in and see ya. Goodbye everyone.